Hi, my name is Ishan Gayaz, and my project is titled Predicting Property Prices in SF Bay Area. This project combined data analysis and machine learning to explore factors influencing property prices and to develop predictive models. So let's move on. The data set and objective. The dataset for this project contains 7,145 entries of real estate data from the San Francisco Bay Area. It included key details like prices, bedrooms, bathrooms, school scores, and commute times. The objective of this project is to analyze the factors that significantly influence property prices, as well as build machine learning models to predict property prices accurately. To sort this data set, I used three machine learning models, which were linear regression for understanding linear relationships, random forest, which was a nonlinear model that captured interactions between variables, and finally XGBoost, which is an advanced gradient boosting model, and it's known for its exceptional performance on structured data. These models were evaluated to determine which one is the most suitable for predicting property prices. So, model evaluation matrix. To evaluate these models, I use three key metrics. Mean absolute error, MAE, which measured average error in absolute terms. Mean squared error, MSE, which penalized larger errors more heavily. And finally, R squared score, which measured the proportion of variance in the target variables explained by the model. In other words, a higher R squared score indicates better performance. So these metrics help compare model performances effectively. So moving on, this is the results I ended up with. So linear regression had the lowest R squared score at 0.63 with an MAE of $703,445, which was not too good. Random forest performed better with an R squared score of 0.78 and an MAE of 279,091. And XGBoost was the best performing model, which achieved an R squared score of 0.8 and an MAE of 269,342. These results highlighted that XGBoost is the most reliable model for predicting the property prices, and Random Forest as well is not too far behind. So, interpretation of the results. Linear regression struggled with nonlinear relationships, which resulted in higher errors. Random forest improved significantly by capturing the nonlinear relationships and feature interactions. And finally, XGBoost outperformed both models by explaining 80% of the variance in property prices. Its low MAE and MSE indicated superior prediction accuracy. So let's let's explore the key factors influencing the property prices. So feature important analysis from the random forest and XGBoost models revealed that the home size, proximity to San Francisco and Palo Alto, and school scores were the most important impactful factors. As you can see, the next slides, random forest and XGBoost show that the home size strongly influenced property prices. So this graph showed which feature importance was important in determining the property prices using the random forest model. The home size and commute times to San Francisco or Palo Alto were the strongest indicators. And school scores also played a significant role, particularly in areas with higher property prices. So, is there a correlation between property price and proximity to San Francisco or Palo Alto? So, this heat map highlights the negative correlations between commute times and property prices. Properties closer to San Francisco and Palo Alto tend to be more expensive. The strong negative correlation underscores the importance of proximity as the key factor in determining property prices. So question number 3, how do school scores influence property prices in various cities? This scatter plot showed the relationship between school scores and property prices. As explained on the graph, areas with higher school scores generally had higher property prices. The upwards trend in the plot confirmed that the school quality is a strong driver in indicating the property value or prices. So next slide. What are the price trends based on the number of bedrooms and bathrooms? So this slide represents the partial dependence plot for the number of bedrooms and bathrooms generated using the random forest model. For bedrooms, the plot showed that as the number of bedrooms increased, the predicted property price rises significantly. Especially for homes with 3 or more bedrooms. However, the trend plateaus after a certain point, indicating diminishing returns. Similarly, the plot reveals a positive relation. Similarly, for the bathrooms, the plot reveals a positive relationship between the number of bathrooms and property prices. So homes with 2 or more bathrooms see higher predicted prices. But like with bedrooms, the trend stabilizes after a certain point. So can we predict property prices based on features like home size, lot size, school scores, and commute times? So this scatter plot compares the actual and predicted prices using the random forest model. The diagonal line represents the perfect predictions where actual prices equal predicted prices. The close alignment of the points with this line indicate a strong predictive performance by the random forest model. And with as you can see down below, the R-squared score of this was 0.79, which proved to be a reliable model for predicting property prices, capturing 79% of the variance. So these were the questions. What factors most significantly affect prices? So all these questions would be answered by the graphs. The home size, school scores, and commute times were the key drivers. Is there a correlation between proximity to SF or Palo Alto? There was a strong negative correlation between the commute time and the prices. There was also a correlation with Palo Alto, which was the second highest, to influence property prices. How do school scores influence prices? So higher school scores were associated with higher property prices, as you saw in the previous scatter plot. What trends based on bathrooms, bedrooms? So larger homes, more beds and baths, obviously commanded higher prices. And can we predict property prices? Yes, XGBoost achieves an R-squared of 0.80, providing accurate predictions. However, I did use random forest, which was pretty close, with a R-squared score of 79%. So, in conclusion, home size, school scores, and proximity to San Francisco are the most influential factors in determining property prices. Among the models tested, Random Forest and XGBoost both performed well. XGBoost did achieve the highest accuracy at 80%, however, Random Forest fell right behind it. So future work could include incorporating additional features like neighborhood specific details or applying these um, techniques to other regions for border insights. And yeah, thank you, and thank you for listening to my presentation. And I'm happy to take any questions. Thanks.